Chapter 16. Dealing with the outside world. Files. In this chapter, you will examine how computer programs get data from an outside source, the text file. Text files are useful because they hold large quantities of data separate from a program that would manipulate that data. These files consist of streams of data and markers that separate one line of data from another. When you work with a text file, you learn to use those markers to help pull data from the text file to use in your program. In this chapter, the text file, how to create a text file, the EOLN marker, the EOF marker, the user versus the file, streams of info and data, the outside world from a program's perspective. So far we have seen that programs manipulate values, which are stored in variables. These values have come either from the programmer or from the user who interacts with the program. Whenever a program deals with a great quantity of data, the data usually comes from an outside source. No user wants to sit at the computer typing for hours. An example of a program that uses a large quantity of data is a program that prints all the batting averages of all the Major League Baseball players in order from highest average to lowest average. Another example is a program that prints all the names of people with the last name Smith who live in the Manhattan borough of New York City. These programs deal with large quantities of data. A. Smith, A.I. Smith, Alan Smith, Alan C. Smith, Alan Smith. Large quantities of data information can be stored in special files that are called text files. Just a couple of examples are the names of all the people in the local phone directory or the names and statistics of the National Hockey League players. These files are different from programming files because what they contain is treated only as text, keyboard letters and symbols, rather than commands. Programming files are different from text files because a compiler will examine the programming file, looking for commands to translate, and then attempt to execute those commands. Programs could become very tedious if they contained both the data to be worked on, as well as the commands to carry out a task. Separating data from instructions can be useful for programmers. Imagine a program that alphabetized and updated a list, any list, like a telephone directory. The directory is like the text file and needs to be changed every year, but the instruction for alphabetizing contained in the programming file probably don't need to be changed. That's one reason why it is useful to separate files that contain only data from files that contain instructions. In this chapter, we will learn how to create a text file. The next step is to learn how to access the contents of the text file. We need to write another program file that does this. There are certain things that are true about text files and the way a programming file reads a text file. As I mentioned before, a programming file, a program, generally gets its data from the programmer or the user. This time we want the program to connect itself to a text file. We want the program to open the text file and read data from it, much as you would open a book and read words from it. Creating a text file. The real power of programming comes when you can connect your program to a text file where much data is stored. In our first example, let's create a short text file of our friends' names and phone numbers so we can learn the basics about text file structures. Consider this list of friends with phone numbers: Carl Brady, 555-1234. Marlo Jones, 789-0123. Jason Argonaut, 888-4567. Jim Collins, 456-2345. Jane Austen, 234-8765. The text file should be thought of as a large piece of lined paper on which we will write data on each line. Data, information, should be put into the text file with some organization. In this file, we have chosen to put a name and then a phone number on each line. But first, we need to create the text file and the name it appropriately. When you open a new file and save it for the first time, use some name like myfriends.dat. myfriends.dat is file name and extension is .dat. We can use the extension .dat to indicate that we are writing a text file, not a programming file. Recall that extensions are used to classify files. You have probably already seen .gif, .jpg, and .doc as examples. Organizing a file through markers. When you write a text file, also called a data file, it is important to give it some structure. As far as the compiler is concerned, a text file is just a sequence of letters and symbols. It looks like this: Carl Brady, 555-1234. Marlo Jones, 789-120-123. Jason Argonaut, 888-4567. Jim Collins, ... The compiler does not care what names you have typed at the keyboard, since it is not looking for programming commands or keywords such as int, main, void, and l, for, while, do, and so on, to translate. It will, however, look for markers on the file. Markers are used to separate data. Since data appears in a stream, just like our CIN stream, the markers are used to provide some organization to what would otherwise be a continuous stream. For this reason, the compiler needs to have some organization imposed on the file. The organization in a file will come from the spacing, the blank that surrounds a value, the blanks that surround a value, and two types of markers that are put onto the text file. The end of line marker. The first marker is an end of line marker, written EOLN. This is used to organize the data in the text file. When you write a file and decide what data will be inside of it, for example, names followed by phone numbers, you then need to use an EOLN marker to separate each piece of unique information. In this case, we want to write a person's name followed by a phone number on each line. After every new person's name and phone number, we hit the return key, which causes an EOLN marker to appear on the file. The file is organized with data followed by these line markers. The end of file marker. When you finish typing a text file, there is an additional marker automatically put onto the file. It is called an end of file marker, EOF. I have used a bullet symbol to represent the marker so you can see where it is placed. This mark is necessary for the compiler or translator that uses the file. See Figure 16.1. Figure 16.1. The file is shown as it appears on the screen, and as it appears as a stream where each name and phone number is followed by an EOLN marker, here a box symbol, and then at the end of the file an EOF marker is used, here the bullet symbol. Screen view, Carl Brady, 555-1234. Marlow Jones, 789-0123. Each is followed by the box symbol mentioned. Jason Argonaut, 888-4567, square. Jim Collins, 456-2345, square. And Jane Austen, 234-8675, square. Stream view, though. Carl Brady, 555-1234, EOLN. Marlow Jones, 789-0123, EOLN. Jason Argonaut, 888-4567, EOLN. Jim Collins, 456-2345, EOLN. And Jane Austen, 234-8675, EOLN, EOF. Reading from a text file. Once you have created the text file, it is necessary to think about the next step, reading from the text file. First, we need to examine how text files are read. Our text file behaves like a CD. You can go back to the beginning of a CD or all the way to the end just by pressing a button on your CD player. You can also burn a CD or just listen to it. A text file behaves in almost the same way. When we first use a text file, we have to open it and indicate that we are going to read from it. Reading a text file is like listening to a CD. Reading means that we will move through the text file, extracting, pulling out copies of values like the names and phone numbers in myfriends.dat that are in the file so that we can use them in our program. When we read a text file, we are not altering it or recording over it, just listening. The term writing a text file is used to describe creating or changing an existing text file by sending values out to the text file. We use the same terminology to describe burning a CD. We are writing new material onto the CD as opposed to just listening to the CD. The steps involved in reading and writing text files, data files, are the same for most programming languages. The first step is to open the text file and then indicate whether you intend to read it or write onto it in the program. Before we do these steps, you need to be familiar with two streams that are used with text files. If you recall, streams are like channels through which values can travel or be stored temporarily. Streams used with files. Text files are an outside source of information for the programmer, just as the user, another outside source, can provide values for the programmer. A text file, often called a data file, provides values as well. Once a text file has been created, it is necessary to access the value from the file so that they can be used in a program. It is important to familiarize yourself with the stream associated with a text file, since these streams provide us access to the file, whether we intend to read from or write to the file. In Chapter 2, we talked about the CIN stream in the C++ programming language, associated with the keyboard. When you work with files, you will probably have to define a stream that connects to the text file. Recall that the CIN stream is already being used and is connected to the keyboard. There are two types of streams used with text files, an in-stream and an out-stream. In the programming language C++, the in-stream type, called if-stream, allows data values to travel from the text file into the program. The out-stream type, called of-stream, allows values to go from the program out to the text file. These streams are very similar to the CIN and COUT streams, and we studied previously. If you recall, the CIN stream is like a channel through which values come into a program from data entered at the keyboard. The cout stream allows values to go from the stream out to the screen. Some languages do not bother with letting the programmer access the stream directly. For example, in the programming language Pascal, the programmer just uses commands like read and write, which simply this process, but also make it more difficult to understand how the computer does what it does. How to access the values in a text file. When you begin a program that will use values that come from a text file, you need to indicate to the compiler that your program will be communicating with an outside file by using an open command in the programming language. We tell the compiler that we will open a file for the purpose of reading from the file. The command could look like this: open myfriends.dat. The next step is to declare an in stream that will connect to the text file. The in stream type is called an if stream. This variable type is found in the header file called fstream.h. Think of this type as short for an in from file stream. We will call the new stream file in. We will call the new stream file in. We can call it anything, even X, but we want to give it a name that reminds us that it is a stream used for reading from a text file. If stream goes to type of file stream, file in goes to name of file stream. Notice that it follows the grammar of declaring a variable of some type. Int x, char initial, double m, if stream file in. Once you have declared the stream type, you are ready to use it in the same way you use the cin stream, which allows you to get values from the user. We use the same extraction operator that we used with cin. We also need to use variable holders for the values that will be pulled out of the stream. In the text file we created previously, we have two strings on each line, a string for the name of our friends, and a string to hold a phone number. All of these are variable holders. String name, number, declaring two strings to hold values from the file. File in, downward arrow, stream name, number, downward arrow, string name. Accessing the contents and displaying them on the screen at the same time. The most useful thing to do with a large file is examine its content by opening a text file for reading. Then we use the appropriate stream with a loop to get copies of all the values from the files. We will use the previous example and expand it in two ways. The first statement we will add is a cout statement, so that we can see the values that came from the text file. They were copied into our variables, name and number, and display them on the screen. String name, number, declaring two strings to hold values from the file. File in, name, number, cout, name, quotation marks, number, end line. This statement allows you to view names and numbers values. The example only lets you see the first two values in the text file. Carl Brady, 55512334. Every time you use the extraction operator with the file stream, you are reading from the file, which is like playing a CD. If you want to read the entire file, like playing a CD all the way to the end, you will have to use the extraction operator repeatedly until everything has been copied out of the file. Note: reading from a file does not change a file. It is similar to listening to a tape or playing a CD. The song is not changed. If you want to see all the contents of the text file, you will need to use a loop so that you can get all 8 lines of data from the file. String name, number, int y. For y is equal to 1, y is less than or equal to 8, y is equal to y plus 1. Opening brace. File in, name, number, cout, name, quotation marks, number, end line, closing brace. Each time this loop spins, a new name and number gets copied into the two variable holders. Then the cout line allows the program to print the values on the screen. Think of the file in stream with the arrow operator as something that pulls copies of values out of the file and then puts them into the variable holders, in this case, name and number. The next line uses the cout stream to send those variables' values to the screen. Note: when using a loop with the same two holders, as in the previous example, the values in the variables will constantly change as the loop spins. Some elementary commands used with files. There is a small group of commands or functions associated with using files in any programming language. Let's look at these commands so that you will be familiar with the types of operations that you can perform on a file. How to rewind a file. When you open a file, there is an imaginary pointer that moves back to the beginning of the file. This pointer keeps track of where you are in the file as the file is being read. It's like moving to track 1 on a CD or pressing the restart button on a CD player. When you read from a file using the file stream we mentioned earlier, the pointer will move through the file as you read from the file. See Figure 16.2. Figure 16.2. A pointer, downward arrow, is shown in different places in a file. The same 5 phone number sequence from before. I'm not going to read them again. Writing values to a file. If you want to add another number or name to a file, there are 2 ways to do this. The first way is to type more data. The first way is to type more data directly into the file, just as we did when we first created the file myfriends.dat. Just add more names and numbers onto the bottom of the list you already have. Carl Brady, 5551234. Marlo Jones, 7890123. Jason Argonaut, 8884567. Jim Collins, 4562345. James Austin, 2348675. This was where the file used to end. William Shakespeare, 7891564. Now it ends here. The other option is to open the file and use the stream that allows data to go out to a file. This type of stream is called an of-stream stream. I think of it as an out-to-file stream. Let's declare a stream of the of-stream type. Of-stream, downward arrow, type of file stream. File out, downward arrow, pointer, name of file stream. Now we can use the insertion operator that we used with the cout stream from chapter 5. The insertion operator will allow the 2 variables values to be sent out to the stream and then to the file. String A is equal to hello, int B equals 78, file out, insertion operator A, B. The text file will look like this. Hello, exclamation point, 78. If we want to put spaces between values in a text file, we will have to put spaces into the stream If we want to put spaces between values in a text file, we will have to put spaces into the stream that is the channel to the text file. Look at this next example where we insert spaces between the values that are going to the stream. File out A, quotation marks, B. The text file will look like this. Hello, 78. To keep the file structure with values on separate lines, we will put a line marker into the stream with the endl command so that a line marker goes onto the file itself. File out A, quotation marks, B, end line. Note, the return key is used to put a line marker directly onto the text file. The endl command must be used to put a line marker into a stream that will send its value to a file. Adding values to the end of a file. If we want to get to the end of a text file, we will have to read it all the way to the end, like playing a CD to the end. Some languages provide a command that allows you to go to the end of a file that you can add more values there. This command is called append. When you append something, you are adding it onto the end of something. For example, an appendix appears at the end of a book. Let's start by opening the file myfriends.dat and appending another name and number to it. Open myfriends.dat, append myfriends.dat, string A equals Mark Holden, string B equals 4561234. Of stream file out A, quotation marks, B, end line. Now the file should look like this. Carl Brady 5551234, Marlo Jones 7890123, Jason Argonaut 8884567, Jim Collins 4562345, Jane Austen 2348675, William Shakespeare 7891564, Mark Holden 4561234. Closing a file. The last thing to do when you are finished with a file is to close the file, just like closing a book when you are finished reading it. Close myfriends.dat. Every language has its own commands for using files. It is important to see how each new language handles files. You need to check to see how you can open the file, write to it, read from it, and then append if possible. The last thing is remember to close the file. On the CD, a program in C++ that creates a text file. Also available is a program that reads data from this text file and displays it on the screen. Summary. Text files, also called data files, are outside sources of data, files of data, that can be introduced into a program. Text files can be one or more lines of data or text and do not have any programming commands. The big advantage of a text file is not having to rely on the user or the programmer as sources of large quantities of data. Phone directories, lists of students at school and universities, and statistics for members of professional sports are just a few examples of large quantities of data. When you name a file, you should use the .dat extension, which indicates that the file type is not a programming file. Text files have two different kinds of markers used to organize information within them: the EOLN marker and the EOF marker. When you create a text file directly, you need to hit the return key to place an EOLN marker onto the file. An EOF marker is automatically placed onto a file when a file is closed after it has been created. Reading from a text file allows copies of values to come out of a file for use in a program. Writing to a text file sends values out to a file through a program. In order to perform either of these tasks, you need to use the two streams associated with text files. In C++, these streams are called of streams and if streams, out to file streams and in from file streams. They work in the same way as the cout and cin streams we discussed earlier. Basic commands associated with file use include commands for opening, closing, and appending to text files. There is an imaginary pointer, like a counter for a CD player, that sits above a file and keeps track of where you left off in the file. When you open a file, the pointer moves to the beginning of the text file. When you append to a file, the pointer automatically goes to the end of the file. Closing the file will cause the file to be closed, just like closing a book.